Welcome back to Unit 7. This is going to be our first set of notes, and this is going to be our 7.1. We're going to be talking about polygons and the properties of a polygon. So a polygon is a closed figure formed by three or more line segments. Those line segments are called the sides. Makes sense, right? This is the side of a triangle, right? These are sides of a triangle. And when we look at the sum of the measures of the interior angles in any polygon, they can be determined by the number of triangles. I'm going to highlight that. The number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. Okay, so here we have our first polygon, and this is the most simplest polygon because it has three sides. So we're going to go ahead and add that and say, okay, there's three sides. And when we look at this picture, this is only has one triangle. Okay. Now we know that a triangle has the interior angles. They're going to add up to 180 degrees. That's the triangle sum theorem. We're very familiar with that. So we can just go ahead and say, okay, well, one triangle, the sum of the interior of those triangles is 180. When we look at a quadrilateral, we can see that this quadrilateral here is being divided in half by this diagonal line, and now we have two triangles. So a quadrilateral is a polygon that has four sides and it has two triangles. Now, since there are two triangles inside of our quadrilateral, we would take our 180 degrees from one triangle and add it to our other 180 degrees from the other triangle, which would give us the sum of 360 degrees. So what we just did there is we took our two triangles and multiplied it by 180 degrees to find the sum of 360. When we look at a pentagon, the pentagon has five sides. And notice how when we added a side, we were increased by one triangle. So now we have three triangles. We take that three triangles and multiply it by 180 degrees, and we can say that the sum of the interior angles is 540. If we look at a hexagon, the hexagon has six sides. And we notice that since we added a side, what increased was our number of triangles. So now we have four triangles. Now, when we take our four triangles and multiply it by 180, okay. Now, a heptagon is just going to increase the side to 7 by 1. But notice the pattern, how when there are three sides, there's one triangle. When there's four sides, there's two triangles. When there's five sides, there's three triangles. So notice how what's happening is that depending on the sides, we are subtracting two to get the number of triangles. Here we subtracted two, and that's how we have two triangles. So that pattern is going to continue on. And since there are seven sides, we are going to subtract two to get five triangles, right? Now to find that sum of interior triangles, we are going to take our five and multiply it by 180, and that will give us a sum of 900. Octagon has eight sides. 8 minus 2 is going to be 6, right? So it's going to have six triangles. And we take the number of triangles, multiply it by 180, and we'll have 1080 degrees for our sum. A nonagon has nine sides. We take our 9 minus 2 is going to be 7. We take that 7 and multiply it by 180. We have 1260 degrees. Decagon has 10 sides. 10 sides is going to have eight triangles. We take that 8, multiply it by 180. We have a total of 1440 degrees. So we can see that there is this pattern happening where we take the number of sides and minus 2 and then multiply that by 180. So you can imagine that the formula is going to work the same way. So we're going to say that the sum of the interior angles equals our number of sides minus 2, then multiply by 180 degrees. Okay, and that makes sense, right? When we looked at our pattern before, we found our sum by taking the sides, subtracting 2, then multiplying it by 180 degrees. So that makes sense why this formula works that way. Okay, so let's go ahead and take a look at number 2. If we have a 21 gon, right, what that means is that we have a polygon that has 21 sides, and we're going to take our 21 sides and plug it in to our formula. So we're going to plug it in right here to n. So the sum of the interior polygons equals 21 minus 2 times 180 degrees. Well, 21 minus 2 is 19, and 19 times 180 degrees, I'm going to write my answer over here, is 3,420 degrees. So did we find the answer? It says find the sum of the measure of the interior angles. Yes, we did. That is the sum of the measure of a 21-gon. So let's look at a regular polygon, right? A regular polygon has very specific parameters. A regular polygon states that if all sides are congruent, then all interior angles, or I should say, then all angles are congruent as well. Okay, so for example, if I have a hexagon, it has 6 sides, and if it's a regular hexagon, then I can put my tick marks here and say, okay, then all 6 sides have to be congruent. And if all 6 sides are congruent, then that means that the interior angles are also congruent. And we'll learn down here when we talk about exterior angles, that exterior angles are also congruent as well when we're looking at a regular polygon. Okay, so the measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angle measures, S, by the number of sides. Okay, so what they're saying is that the sum can be divided by the number of sides to find one angle measure. And that makes sense, right? If I have a triangle, and if it's a regular triangle, then all 3 sides are going to be the same, and all angles, all the interior angles are going to be the same. So I can take 180 degrees, which is the sum of my interior angles, and divide it by 3, because there's 3 angles, and that will tell me that each angle equals 90 degrees. We can use that same method of thinking when we're looking at a regular pentagon, except instead of 3 sides and 3 angles, we have 5 sides and 5 angles. So what is the sum of the interior angles of a pentagon? Well, we did go over that in our notes. For a pentagon, that has 5 sides, the sum is 540 degrees. So if I take my 540 degrees and divide that by however many angles there are, in this case there's 5, then I'm going to say that each angle of a regular polygon has to equal 108 degrees. Same thing right here if I look at a regular 18-agon, right? I know that a regular 18-agon I can find the sum of the of the interior angles by taking the sum equals 18 minus 2, and then I'm going to multiply that by 180 degrees. Well, 18 minus 2 is 16, And 16 times 180 is 2,880 degrees. Now I'm not done because this is just the sum of all of the interior angles. I still need to divide that by however many angles there are to find the value of one angle. So if I take this and divide it by 18, one interior angle will be 160 degrees. Let's look at the sum of the exterior angles. So right here, it tells us that the exterior angles are supplementary to their adjacent interior angle. Find the measure of each exterior angle on the polygons below, then give the sum of all exterior angle measures. Okay, well, we know that supplementary means that two angles are going to add up to 180 degrees. And it has to be the adjacent angles, which makes sense, right? This is a line. So if these two angles are adjacent and they are supplementary, then they're both going to add up to 180 degrees. So if I take my 180 degrees and minus 79 for this side, then I can say that the exterior angle is 101 degrees. Same thing here. If I subtract 180 by 40, I'll get a angle left over, angle degrees of 140. And if I subtract 180 from 61, then I'm left with 119 degrees. Now that I've found the exterior angle measures, I can add them up to find the sum. Once we plug that in a calculator, you'll realize that the sum is 360 degrees. Now let's think about this logic. When we talk about going around in a circle, we know that it takes us 360 degrees to make a complete circle. That same logic applies when it comes to going around a polygon. If I go around each of these polygons, I will find that each of the exterior angles are going to have a sum of 360 degrees. No matter the polygon, it will always be 360 degrees. So for the next portion of your notes, it says, what can you conclude about the sum of the exterior angle measures of a polygon? You can write in your own words that all exterior angles of any polygon will add up to 360 degrees. Okay, let's take a look at number 10. If the exterior angle of a regular polygon measures 40 degrees, how many sides does the polygon have? Well, let's think about this for a minute. We know that the exterior angles of any polygon is 360 degrees. And they're telling us that some polygon, we don't know which one it is, but a regular polygon measures to be 40. So if it's a regular polygon, that means every exterior angle has to be the same if it's regular, right? It has to be congruent. So let's think about this logic. If all of my exterior angles are congruent and they're all 40, how many 40-degree angles can I fit into 360 degrees? Well, I'm going to take my 360 and divide it by 40, and that will give me a total of 9. So I can fit 9 40-degree angles into 360 degrees.